When we condense logarithms, we're pushing them together. Sometimes you're going to be asked to take a logarithm that's already been pushed together and expand it back out. It is literally the exact opposite process of what we just did. However, it uses the same exact skills and properties that we already know, but just to go in one direction rather than another. All right, so trust me, it's not going to be too bad. Let's review a couple topics. Let's get into some problems and let's see how we do. So again, just as a quick reminder, if you didn't see our last video, in order to expand or condense logarithms, you're going to have to know three properties. Okay, we already covered these in previous videos. Go ahead and click the link if you haven't already done that. And while you're at it, go ahead, like, comment, and subscribe. Help us out. All right. So let's just take a look at the product rule. Okay, we know that if we have the log with some base of xy, we know that we can write this, expand these two essentially because we're having the same base. So you have log base bx plus log base by. It's the product rule because whenever you are adding two logs with the same base, you can write them under one log, but you can have them multiplied together. Quotient rule is the exact opposite. If you are dividing two things within one logarithm, you can actually just rewrite it so that way there's a subtraction sign there and just have the log base with the numerator here minus log base with the denominator right there. Okay, so in that one, the order does matter. And the power rule just says that, hey, if you're taking the logarithm and within here you have some kind of exponent there, you can write this down here as a coefficient. And that one is super handy. All right, so now we know those three logarithmic properties. Let's go ahead and get into some practice problems. So let's take a look at our easy problem, okay? We're taking the log of x to the fifth divided by y to the power of 3. So right off the bat, I know that I am dividing, so I know that I'm using my quotient rule. So let's expand that to involve subtraction in this process. So if I have log of x to the fifth minus log of y to the third, good. Okay, I expanded that out. So instead of one logarithm, I have two, but I'm not done just yet because I have exponents here and here. I need to kick those out to be coefficients. So once I write my 5 out in front, I'll have log of x. And once I have my 3 out in front, log of y, I am now done. This is now, that's the eraser, that's not a highlighter. I am now done. This is the expanded version of this up here. Okay, let's take a look at a medium problem to see if we can use even more properties to help expand out the given logarithm, all right? So when we have a medium here, we're saying that we have log of the cubic root of y to the fifth divided by z squared over z squared times x to the fifth. So again, I know that I have a division problem right here, so I know that I'm going to be using the quotient rule. Let's start with that. So let's expand this to write two separate logarithms with subtraction. Now, I'm going to rewrite this as log of the cubic root of, not x, y to the fifth minus log of z squared x to the fifth. And I just want to say that it's always best practices to include these parentheses because you never know how big or complicated your problem is going to get, and those parentheses will really help you stay organized. So don't forget to include them, all right? So now I know that I have log of the cubic root of y to the fifth. And what I can now do is I can rewrite this because I know that I am multiplying two different things here with the same logarithm. So I can actually use my quotient rule here. And the reason why I want you to use parentheses is because you have to subtract log of z squared plus log of x to the fifth. The reason being is that you are subtracting this entire logarithm right here. And if you're going to expand this logarithm right here, well, then you need to make sure that you are subtracting by whatever that expansion is in its entire quantity. So don't forget to include those parentheses because this right here, if you, I'll show you in just a second actually. If we have log cube y to the fifth minus log z squared minus log x to the fifth, if you did not include these parentheses, then you would have minus log z squared plus log x to the fifth. This wouldn't change because of this distribution right here. So you got to make sure that you're including your parentheses to get these problems right. Okay, so how can I further expand this? Well, I can see that I have a cubic root of x to the fifth, and you know what? I'm going to rewrite that in exponential form because it'll make my life a lot easier. If only my handwriting was nicer. Minus log of z squared minus log of x to the fifth. Okay, so now I have everything written in exponential form. So again, what do we do with exponents? We kick them out as coefficients. So let's rewrite this as 5/3 of log y minus 2 log of z minus 5 log of x, and I am done. This is the answer that I am looking for. I can't really expand this any further. I have all my exponents written as coefficients. I've expanded all my logarithms. This is looking fantastic. So this right here is the answer that you're looking for. And last but not least, let's take a look at a problem that might be a little bit harder, but again, it's the same properties, it's the same steps over and over. It's just that they might look a little bit more complicated. That's the only kicker. So let's say we want to find a numerical value of a log expression. So our log expression is this right here. The log is equal to, okay, on the top we have the square root of b to the 5th times c, and then in the denominator we just have a squared. And we're given that log of a is equal to -5, log of b is equal to positive 10, and log of c is equal to 4. Okay, well that doesn't really help us right now because I don't see just log of a to substitute a -5, and I don't see just a log b to substitute 10 in. So again, let's unpack this, let's expand it, so that way we can actually get this into a form where we have a log of a or a log of b or a log of c that we can plug these numbers directly into to get an answer. All right, so let's actually expand this one out. So if I have log of the root of b to the 5th times c minus log of a squared, okay, that's a great start. Let's deal with this square root. So now that with the square root, I'm taking everything to the power of 1/2. So what that would mean is I now have log of b 5/2 times c to the 1/2, okay, minus log of a squared. Okay, so all I did was I just rewrote that square root in exponential form for each of those terms. So what that means is that before, when I was using my quotient property, now I can use my product property because I'm multiplying. So I'm going to write log of b 5/2 plus log of c 1/2 minus log of a squared. Okay, so now let's go ahead. Let's move those exponents down as coefficients using our power rule, which means that we are going to have 5/2 log base b plus 1/2 log base c minus 2 log base a. And now I'm finally seeing something that represents what I see up here. I have a log b, I have a log b. I have a log c, I have a log c, I have a log a, and I have a log a. So I can finally plug in those those values that were given before into what we're working with now, and I can finally get a numerical answer. So I'm still going to have 5/2 out here, but what is log of b equal to? 10. So 10 is going to come down and replace that. So this will be 5/2 times 10. I'm going to have 1/2 times log c, which is going to be 4, minus 2 log a, which is going to be -5. Right? And then once I finally just do the algebra here, oh, whoops, I totally did that wrong. Log of a is not log of -5. It is just -5. Okay. So now all you have to do is just figure out this basic algebra here, and you'll be getting your right answer. So 5/2 times 10, a couple different ways to think about it. I like to cancel out the 2 and the 10, so this is 5. Then I have 5 times 5. It's going to give me 25. You can put it in your calculator. Doesn't matter. 1/2 of 4 is 2. And then -2 times -5, that's going to be a positive 10. That's going to give me 35 plus 2. That's going to give me an answer of 37. So again, just because something looks a little bit difficult, it doesn't mean that it actually is. You just have to use the properties that we were working with this entire process, this video and last video, break it down, expand what you can, and then get these logarithms here to look like what you need them to, so that way you can plug in these values and substitute them, so that way you can get one solid answer at the very end. Okay, I hope this helped. If you did find it helpful, please like, comment, and subscribe. Let us know what you would like us to work on next. We are pumping out videos every single week, and yeah, we're here to help you out. So just let us know what you guys need. All right, take it easy, take care, have a great week. See you.